So today we are going to start Unit 2. And Unit 2 is going to deal with some functions and coming up with those, explicit equations and things of that nature. And then also dealing with how to solve them. Okay? So we're going to start today with a little bit what we call a boot camp. Just kind of refreshing your memory on things that you needed, that you already learned back in last year's math, or the year before that, or the year before that, bringing that up and getting that up into the forefront of your brain, out from the dusty old cobwebs. Okay, so I want to talk a little bit about, this isn't on your note, this isn't on this sheet, but this sheet will be due on Monday then. Okay. So this not only doubles as your notes, but it's also going to double as what you're doing today in class. If you get it done, you can turn it in. If you don't get it done, then that becomes your homework. Okay? Right? So I want to talk a little bit about domain and range, because domain and range come up in numbers number 3, 4, and 5. Okay? So the domain is all the possible values of a function, or of the x function, okay? The inputs, if you will, okay? Domain is inputs, okay? So if I were to have this function right here, we can just do this one right here. If I were to have this function, I would plug in different values for x. Give me a value of x that I could plug into that function. 2. I could plug in 2. Yes, I could. Give me another one. 1. Give me another one. You guys are missing the easy one.
6.
Nope, that's even easier than 6.
3.
0 is the easiest of the easies to put in. Yes. And then let's go -1, just so we get a -1 there in there too. Okay? So the domain of this function right now, as we have it written, would be from -1 to +2, because that's all of my x values that I have in there. Okay. Then we plug in those numbers. 2 squared is 4, times 3 is 12. Oops, I forgot to put my y's here, or my f of x's. 2 to the first power is 2, times 3 is 6. 2 to the 0 power is 1, times 3 is 3. 2 to the -1 power is 1/2, times 3 is -3/2. Okay? So right now, if this were my function, I would say that my domain would be all values of x from -1 to +2. That's how I would write it. Then, my range is going to be my outputs, or my y values. Okay? And so that's going to go from 3/2 all the way up to 12. Okay? Because that's what the values of my y's go from. When we're doing this notation, it is always small, your smallest number on the left, your biggest number on the right. Okay? Always small to big, left to right. Okay? Then, if I were to graph this function, I would come over here and I would be at -1. 3/2 is 1.5. 0, 3. 1, 6. 2, 12. And I would just connect those. I wouldn't extend it any further than just those, because we restricted our domain, which then restricts our range, which restricts our graph. We just take a little part of the graph. With me on that? Okay? Love it. So if you look at numbers 3, 4, 5, and 5, your domain here is restricted, so you should always start with -2, -1, 0, 1, and 2. Because it's always what your domain is restricted to. Okay. One other thing I want to talk about before I turn you loose on this is, let's do one problem from the 4 in number 1. I don't care which one. First letter A to D, I hear we're going to do. B I heard first. Okay? All right? So the first thing that I would do here in letter B is I would combine my like terms. Okay? So then this would become 2x plus 16 equals -5x minus 12. Okay. Now the goal when you're solving an equation is to get your variable on one side and your numbers on the other side. It doesn't matter which side you put the variable on, you just got to get variables only on one side. Okay? So you have to make yourself a choice. The choice that you have to make is left or right for your variable. I'll leave it up to you. Left. I heard left first. So if I'm going to leave the variables on the left side, that means that I'm going to have to then move this 5x, and when I move that 5x, I do the opposite. So it's -5x as written in the problem. So the opposite of negative is added, or is positive. So I have to add 5x to both sides. If we would have chosen right, then we would have subtracted 2x from both sides. Because the 2x is positive, to move it, I would have to subtract it. With me on that? Okay? The nice thing about that, then, is those cancel each other out. And that leaves me with, if you have 2 pencils and I give you 5 more pencils, you now have 7 pencils. And so you get 7x plus 16 equals -12. We now have successfully put all of our variables on the left side, which means we have to take our numbers and we have to put our numbers on the right side, which means I got to get all the numbers off of the left side. So I'm going to subtract 16 from both sides, because that cancels that out. And then that leaves me with 7x equals -28. So we have successfully gotten variables on one side, numbers on the other side. The problem that we have is we don't have our variable all by itself. So what is 7 doing to x right now? Multiplying. What's the opposite of multiplying? Division. So I'm going to divide here now at the end by 7. These now cancel out. And that leaves me with x equals -4. That's my final answer. Yeah. The rest of the time, so you've got 25 minutes. The rest of the worksheet, you've got a few problems to do, front and back, are all yours for the remainder of the time. So your goal is to get that done. Again, if you don't get it done today in class, then take it home and get it done over the weekend. If you need a calculator, we've got calculators up here. If you want to check your work with me, that's fine. We can check our work to make sure that you're doing them right. I'll have the answer key out ready to go. Questions, comments, concerns, clarification?